In this video, I'm going to go through Review 1 for Unit 1. If you have any specific questions, you can go to the description to jump to whatever question you need help with. So for number 1, if the measure of angle NPM equals 2x minus 7, so remember, we name an angle with 3 letters, so if I trace it out, NPM, it's going to be that angle right there. So I'm just going to mark that in my picture as 2x minus 7. The measure of angle MPQ, that angle right there, is x plus 10. And the measure of angle NPQ, which is just the big angle, the whole angle, is 117. Find the measure of angle NPM. So they really want us to find 2x minus 7, but in order to do that, I need to set up an equation to solve for x yet. So this is an addition postulate, but applied to the angles. So if I'm looking here, I've got one part of an angle, and I've got another part of an angle, and I know what the whole angle should be. So I could take the sum of the parts by adding 2x minus 7, one angle, adding that to my other angle, and setting it equal to the whole. So I'm going to start by combining like terms. 2x and x makes 3x, minus 7 and 10 makes plus 3, equals 117. To undo the positive 3, I'm going to subtract 3 on both sides. That should be 117. So I'm left with 3x on one side, because the 3's reduced to 0, and 114 on the other. So to undo that coefficient of 3, it's linked by multiplication. So I'm going to use division, my inverse operation, and I find that x equals 38. Now, that's not my answer, because remember, we were looking for NPM. So I need to take that 2x minus 7 and substitute that 38 back in for x and see what my numerical answer is. So when I do that, I get 69 for angle NPM. For number 2, if AC is 3x minus 20, AB is x plus 5, and BC is x plus 10, solve for x. So this is another addition postulate. I know we have a straight line segment here, but I'm not going to be thinking about anything that, oh, I see a straight line, so I know I have 180 degrees. That's true, but I don't have any angles here. I only know anything about lengths of segments. So again, I'm going to say to myself, the sum of the parts should equal the whole. So this is another addition postulate. So if I add up one part and add it to the other part, so I'm taking AB and I'm adding it to BC, and together, that should be the entire length of the segment AC, because I know it's a straight line segment. So I take x plus 5, x plus 10, I sum them, and I set it equal to my whole, 3x minus 20. Again, I'm going to combine like terms. X plus x is 2x, 5 plus 10 is 15. And I've got a little bit more work to do to solve this equation. So I'm going to add 20 to both sides to get rid of that negative 20. And I'm also going to subtract 2x on both sides to try to group all of my x's together on one side of the equation. So what happens here is the 2x is reduced to 0, minus 20 and plus 20 reduces to 0. I'm left with 35 on one side and x on the other. So x equals 35. They didn't ask me to solve for BC or AC, so I don't need to substitute back in, but make sure you're just aware of what you're looking for in the problem. For number 3, use the diagram below to solve for x. Remember, if you see that box there where with two lines intersecting forming an angle, that's showing you that that's a right angle or 90 degrees. So what that means is that if two lines are perpendicular or intersect at right angles, that means that all of the angles formed by those intersecting lines, those 4 angles, are all right angles. So that right angle up there I don't particularly care about, but I do care about this right angle right here. I notice that 40 makes up one part of the angle, and 6x plus 2 makes up the other part of the angle. But together, they should sum to 90 degrees because I know that's a right angle. So these are called two complementary angles because they sum to 90 degrees. One way you could solve this is by taking 6x plus 2, adding 40, and setting it equal to 90 because you know the lines are perpendicular and you know together they should make a right angle. The other thing that might save you a little bit of work is that if you realize one part of your 90-degree angle is 40, you could subtract from 90 to find out what your missing piece is. So this piece right here should be 50. So to save yourself a little bit of work, you could actually start with the equation 6x plus 2 equals 50, because this representation of the angle should be the same as the angle measurement. So I'm just going to solve that equation real quick. Subtracting 2 on both sides, I get 6x equals 48, and if I divide by 6, I get x equals 8. Again, I don't need to solve for anything else, I just need the value of x. For number 4, given k is the midpoint of JL, JK equals 6x plus 7. I'm going to put that above the segment. KL equals 9x minus 2. Find JL. So they want us to find the whole length of the segment here. Before I can do that, I'm going to need to figure out what x is so I could substitute in and find some values. The problem is all they tell me is that k is a midpoint. So remember, the definition of a midpoint is that it bisects a line segment and cuts it into two congruent parts. So JK should be the same measure as KL, because a midpoint splits it right in the middle, so the two halves are congruent. So equation-wise, I'm going to set one half equal to the other half. I'm going to add 2 on both sides to get rid of that minus 2, and I'm going to subtract 6x on both sides to get rid of that 6x. There are lots of different ways to solve these equations, so don't stress if your equation looks a little bit different than mine when you're solving, but you should have the same equation to start with. So 7 plus 2 is 9, 9 minus 6x is 3x, and when I divide out that 3, I get x is equal to 3. Now again, be careful, because I didn't ask for x, I asked for the whole length of the segment all the way from J over to L. So I'm going to start substituting back in that 3 to see what my lengths are. So if I do 6 times 3 plus 7, 6 times 3 is 18, plus 7 is 25. Now if you know anything about midpoints, remember that if one side's 25, the other side should also be 25. And you could substitute into 9x minus 2 just to check. So if I want to find the entire length of JL, I could add 25 and 25 and get 50. Number 5. If MN equals 5, NO equals 7, and MO equals 12, are the points collinear? Why or why not? Explain. So remember, collinear points are just 3 or more points that lie on the same straight line segment. So we want to verify if MO is a straight line segment that N falls on. So one way to do that is to check to see if the sum of the parts of the line segment is equal to the whole. So my two parts are MN and NO, and my entire line segment is represented by MO. So in this case, the numbers check out, because if I add 5 to 7, and I want to check to see if that's equal to 12, yes, that is in fact true. So if I'm explaining myself, I want to first say yes, M, N, and O are collinear. And my reason being is that because the shortest distance between 2 points is a straight line segment, and they tell me what that line segment is, and the sum of the line segments in between them add to the full line segment, it must be the case that N is on the same line that connects M to O. So the big idea here is that there wasn't any detour coming from M to N back up to O, because the lengths are the same. Because remember, the shortest distance between 2 points should be a straight line. So if the distance from M to N and then from N to O was greater than 12, then N would not be on the same line segment, and it would not be collinear. Number 6. In the diagram shown below, it is given that line EAH and the line FB intersect at A. EAG is right. I don't know if that helps me, but I'm going to mark it with a box anyway. Give two different angles that are supplementary to angle BAE. So that angle down there. Remember, supplementary angles just mean that they sum to 180 degrees. If you don't remember what 180 degrees looks like, it's a straight line segment. So generally for supplementary angles, I'm adding two or more angles that are going to sum to 180. So something like if I had a 60 degree angle and a 120 degree angle, that would be a linear pair or supplementary angles. So if I'm just taking my ruler to try to see what lines are here, I'm noticing that if I'm looking at line FB, to complete the full 180 degrees, I would need to have this little angle over here, and if I label it with the letters, that's angle FAE. Or it could be angle EAF, as long as the vertex A is in the middle of your naming. Another angle you could use, if you look at the other line they give us, EAH, if I want to complete the full 180 degrees, I would just need to add that little piece right there, or angle HAB, because together they form to make that straight line EAH, which I know is 180 degrees. And from there, we can make an inference. It says, what must be true of these two angles? Well, think about it. If EAB was something like 120 degrees, then if I know, looking at line FB, that the two angles FAE and EAB are supplementary, then FAE must be 60 degrees. I can make a similar argument to say that if I'm just looking at this line EH, if BAE is 120 degrees, HAB should also be 60 degrees, so they sum to 180. Notice that both of these are 60 degree angles, so we can come to the conclusion that they are congruent. And the reason they are, remember we had a special name for these are called vertical angles. When we have two lines that intersect, the angles opposite from one another are always congruent, specifically for this reason. Number 7. Two angles are complementary. Remember that means they sum to 90 degrees. So before I even think about anything, in my head I'm thinking about an equation where there's one angle plus some other angle equals 90 degrees. So I'm going to keep reading. If one angle is 2 more than 3 times the other, find the two angles. Well, I'm going to label X as one of my angles, just because I don't know what it is. And my other angle is 2 more than, so that means plus 2, more than is signifying the operation addition. 3 times is multiplication, and it's 3 multiplied to the other angle, X. So to write that as one expression, I could write that as 3x plus 2. So now I have my two angles that I'm going to sum and set equal to 90. So if I combine my like terms, x and 3x is 4x, plus 2 equals 90. I'm going to subtract 2 on both sides. 4x equals 88. And when I divide out that 4, I find that x is equal to 22. Now, they told me to find two angles. I labeled one of my angles as x, so I'm already done for one of my angles. But my other angle, I labeled as 3x plus 2. So I still want to substitute back into that 3x plus 2 with the value of x that I found there. So I'm going to do 3 times 22 plus 2, and I end up with 68 degrees. So those are my two angles. Now, you should be able to check yourself to see if you're correct, because if they're complementary, they must sum to 90 degrees. And when I add 68 to 22, that is in fact the case. For number 8, if two angles are supplementary, now this is a very similar problem to number 7, only instead of setting it equal to 90 because they're supplementary, that means my angles should sum to 180 degrees. So when I'm setting up my equation, it should be one angle plus some other angle equals 180 degrees. So let's keep reading. If one angle is 36 less than twice the other angle, find the two angles. Again, I'm going to label just one of my angles as x, and 36 less than is subtracting 36 from whatever the twice the other angle is, And I know twice means I'm multiplying by 2, and I already labeled my other angle as x. So the expression I can represent the other angle with is 2x minus 36. Again, I'm going to combine like terms and solve this equation. I'm adding 36 to both sides to undo the minus 36. I end up with 3x equals 216. And when I divide out the 3, I'm left with x equals 72 degrees. This is one of my angles. Don't forget to substitute back in because it said find the two angles. So I'm going to plug into 2 times x, which is 72, minus 36. I'm just going to type that into my calculator just to save myself some work, and I find my other angle is 108 degrees. Now you don't really need to substitute in if you know that the angle should be supplementary, but I always would just to check to make sure that your work checks out. For number 9, two angles are along the straight line ABC. Angle ABD and angle DBC is in a ratio of in a 7:5 ratio. So I'm going to label one of the pieces as 7x and one of the pieces as 5x. So when I divide these two angles against each other, it should always reduce to a 7:5 ratio. Find the measure of angle ABD and find the measure of angle CBD. So because they're along a straight line, these two angles are also supplementary because they form a straight angle when they're adjacent. So I'm going to add my two angles, 7x plus 5x, and set it equal to 180 degrees. 7 plus 5 is 12, and when I divide out that 12, I find that x is equal to 15. Now, they didn't ask for x, they asked for the measures of the angles, so I'm just going to plug back in here. 5 times 15 is 75, and 7 times 15 is going to be 105. So the whole 7:5 ratio idea is that if I compare these two angles, 105 to 75, I could divide them both by 15 if I want to just look at this fraction a little bit smaller, and this would still reduce down to a 7:5 ratio. So that's one way to check just to make sure that you got the correct answer and that your setup was okay for the 7:5 ratio. Number 10. Line PQ bisects MN at R. So I'm just going to draw a picture before I even keep reading. So line PQ is bisecting MN. I'm going to give myself a line segment MN. And I've got a line coming down through it that's bisecting it. I'm going to label that as PQ. Remember that a bisector goes through the midpoint of a segment and cuts a segment into two congruent parts. To show that those parts are congruent, I'm just going to use a little tick mark on both sides. So in this case, because I know PQ is bisecting MN, I know that MR is equal to RN. So it tells me that MN is 60, which is the whole length of the segment, and MR equals 3x. There's a lot of different ways you could solve this one. One thing I'm noticing is that if MR is 3x, RN should also be 3x, because I know that the line is bisecting MN, so both halves should be congruent on either side of R. And if I know that the whole line segment is 60, I could set up the equation the sum of the parts, both halves, summed together, equals the whole. I get 6x equals 60, divide by 6, divide by 6, I get x equals 10. You could also make an argument that if 3x is half the length of MN, you could just divide 60 by 2 to get 30, and say that half of your segment should be 30, and solve that equation from there to get the same answer. So for some of these, there'll be a couple different ways to do it. Number 11. Find the measure of the missing angles. So there's a lot going on in this picture, but there's two angles I need. I need to find x, and then I need to find that angle y right there. One thing I notice is that I have a right angle right here, so that's 90 degrees. I've got 51 degrees right here, and if I'm looking at this straight line that I have, all of the angles that make up the straight line should sum to 180 degrees. And I already have two of those angles, so I could set up an equation x plus 51 plus 90 equals 180. And you could solve that equation. Realistically, if there's not a lot going on in these equations, I'll just take 180 and I'll subtract both 90 and 51 just to do everything in one step so I don't have to work with an equation, but it's up to you how you want to approach this. When I do this, I find that x is equal to 39 degrees. Now, if you didn't see that straight line, or if you were thinking a little bit harder, you might say that, well, if the whole line is 180 degrees, and this piece is 90, the other half should be 90 as well. So you could just say, oh, well, 90 minus 51 is 39 degrees, and you don't have to go through any of that process. So notice how many different ways there are to approach this depending on how you see the angles. So I have x, and if I'm thinking about vertical angles, remember that anytime two straight lines intersect, the angles on the opposite side, so I call those the bow tie angles, or the vertical angles, which is the specific name, are always congruent. So if one side's 39 degrees, the other side can be 39 degrees too. So to get y, which is this full angle right here, I already know this piece is 90, I know the other piece is 39, so I can sum those together to find that y is equal to 129 degrees. For number 12, this one is hard to start, but I'm going to read it first. Segment DG is perpendicular to GA. I'm given segment CE and segment AB, and I want to find the measure of angle BGF right there. Couple things. If my line segments, or my lines, are perpendicular, remember that means that they intersect to form right angles. So I know both of those are right angles in case that helps me later. That does in fact help me because I notice that I have 6x over here, and for the last problem we talked about vertical angles, because CE is a straight line segment and because BA is a straight line segment, I can assume these are vertical angles and therefore congruent. So I'm going to put 6x on the other side as well. Now that I know the segments are perpendicular and that this should be a right angle altogether, I can set up an equation with these complementary angles here. I can say 6x plus 4x should sum to 90 degrees. So if I do a little bit of simplifying, I find that x is equal to 9. So that's helpful because I can start plugging in and filling out what some of these angles are numerically. If I plug in here, 6 times 9 is 54. 5 times 6 is, 5 times 9, if I'm plugging in, is 45. Plus 20 is 65. And I'm not even going to worry about these two angles over here because I'm already noticing something. I'm noticing that BA is a straight line segment. So all the angles on one side of it should sum to 180 degrees. So what I'm going to do is I'm going to look at these three angles, noticing that I know one of them's 54, one of them's 65. I could subtract from 180 to figure out what that missing angle is. So if I subtract 65 and 54 from 180, I find that the missing angle that I'm looking for is actually 61 degrees. There are lots of different ways you could do this. You could figure out what these angles are and then subtract from 360 once you know everything, because remember the angles around a point should sum to 360. So just make sure you're keeping your eyes peeled for different ways you could solve these problems.